Hello students, in the last episode we discussed arithmetic progression known as AP. We solved many problems there. Somewhat similar progression is the next one which we are going to take it today, and that is known as geometric progression. Look at this: 1, 2, 4, 8. Can you get the next term? Yes, it is 16, then 32. What is happening here? Every term is double of the previous term. Similarly, this sequence, every term is triple of the previous term. So, any sequence in which the terms progress with a constant ratio, that is called geometric progression. In general, we will have terms like first term, AR square, AR cube, and so on. Here, every term is progressing with a ratio of R. This R is called common ratio, and A is your first term. Now, to avoid triviality, we assume that R is not 0, otherwise all terms will be 0. Further, if R is 1, all terms will be A. So, there is no progression, but it is valid. But in general, R is not equal to 1 and R is never 0. Now, as before, we have to find the nth term and also sum of n terms. Look at this: T1 is A, T2 is R times A, T3 is again R times AR, that is AR square, and so on. We can expect that T16 is simply A R raised to power 15. Now, this 15 is 1 less than 16, 2 is less than 1 less than 3, like that. So, we can guess that in general Tn is A times R raised to power n minus 1. But mere observation of this pattern, we cannot conclude logically that Tn is always A times AR raised to power n minus 1. So, we must prove it. The best way is to prove it by mathematical induction. We have Pn is equal to Tn is A times R raised to power n minus 1. For P1, we have T1 is equal to A R raised to power 1 minus 1, which is clearly true. Now, assume it for K. So, Pk be true. This means Tk is equal to A raised to power A times R raised to power k minus 1. Now, for Tk plus 1, we require A times Rk minus 1 whole times R. That gives A times R raised to power k, which equals A times R raised to power k plus 1 minus 1. Thus, Pk plus 1 is true. So, the result is true for all n belonging to n. Thus, we have established the formula for the nth term, which is simply Tn is equal to A times R raised to power n minus 1. Our next step is to work out a formula for the sum of n terms. Suppose we have Sn denoting the sum of n terms, which is simply A plus AR plus AR square and so on up to AR n minus 1. Now, here we play a small trick. We write r times Sn in this manner. And now we subtract it. Here we get 1 minus r Sn. The first term is a. From second up to nth term, all terms get cancelled. We are left with only Arn. Thus, Sn is equal to a common 1 minus Rn upon 1 minus r. It can also be written as a times Rn minus 1 upon r minus 1. So, we have two forms for Sn. Usually, we use the first form when r is less than 1 and second form when r is more than 1, but both are correct in both cases. It is only a matter of convenience. Now, with these two formulae, we can start solving any type of problems. Let us take a problem. Here the sum is given to be 819 for 3 terms. Also the product is given to be 531441. We are required to find the common ratio as well as the 3 terms. We can assume the terms to be A, AR, AR square as the normal case, but as a special case in this kind of problem, we better use the terms as A upon R, A and AR, because definitely here the first term is A upon R and the common ratio is R. As per the given problem, the sum, that is A times 1 upon R plus 1 plus R equal to 819, while the product, that is A upon R times A, AR, that is A cube is equal to 531441. So, we have A cube is equal to, now this 531441 is actually 9 raised to power 6, which is equivalent to 81 cube. Now, this gives A is equal to 81. Having found A, now we go for value of R. We had the equation A times 1 plus R square upon R is equal to 819. Here A is already found to be 81. So, we have 81 times 1 plus R square equals 819 times R. We cancel out 9 from both sides. So, you have 9 plus 9R plus 9R square is equal to 91R, which eventually becomes 9R square minus 82R plus 9 equals 0. By splitting the middle term, we get 9R square minus 81R minus R plus 9 equals 0, which comes to be 9R minus 1 times R minus 1 equal to 0, R minus 9 equal to 0. So, we have R is 1 by 9 or R is 9. This implies 9R square minus 81R minus R plus 9 equal to 0, which gives 9R minus 1 times R minus 9 equal to 0. Eventually, it gives R is 1 by 9 or R is 9. First we take R is 9. We already know that A is 81. Our first term was, remember, it was a upon r. So, it is 81 upon 9, then 81, then 81 times 9. So, as for the value of r equal to 9, our sequence terms are 9, 81 and 729. But if you recall, we had one more value of r, namely r is 1 by 9. With that value of r, we get the sequence as 729, 81 and 9. So, both are valid answers. So, we must write both the answers in the examination to get full marks. Now, we take another problem. If the 4th, 11th and 18th terms of a GP are x, y and z respectively, prove that x, y, z are also in GP. In any problem, we must look at the problem first whether A and R are given. If they are not given, assume it. Suppose first term is A and the common ratio is R. So, as per condition, we have T4 is AR cube, T11 is equal to AR power 10 and T18 is AR raised to power 17, and this is given to be x, y and z. We have to show that x, y, z are also in GP. To show that, we require to show that y upon x is same as z upon y. So, now we have y upon x, that is AR power 10 AR cube gives R7. Also, z upon y equals AR power 17 upon AR power 10, this gives R7. Thus, we find that y upon x is equal to z upon y. It means x, y, z are in GP. We take one more type of problem. Here, at the first look, the problem is not directly of GP, because the sequence 7, 77, 777 is not in GP at all, but somehow we can bring GP into it. Suppose we have S is equal to 7 plus 77 plus and so on. This equals to 7 times 1 plus 11 plus 111 and so on. Again it equals to 7 by 9, 9 plus 99 plus 999 and so on. That equals to 7 by 9, 10 minus 1, 10 square minus 1, 10 cube minus 1 and so on. If we want n terms, then this is 7 by 9, 10, 10 square up to 10 raised to power n minus 1 plus 1 n times. Now, look at this. The given sequence are not in GP, but a part of it is in GP. So, we get 7 by 9, 10 raised to power n minus 1 upon 10 minus 1 times 10 minus 1 is coming n times, so it is just n. This is 7 by 9, 10 upon 9, 10 power n minus 1 minus n. Finally, we get 70 upon 81, 10 raised to power n minus 1 minus 7 by 9 as our result. So, this is the sum of n terms of the given sequence 7, 77 plus 777 up to n terms. फिर से बोलें? Okay. Equal to 70 upon 81 10 raised to power n minus 1 minus 7 by 9 times n. Dear students, today I introduce you to geometry progression. First of all, we proved the formula for nth term and also sum of n terms. In the first case, we used mathematical induction to prove it. Then we worked out many problems to highlight the application of this formulae. In our next episodes, we take some more problems in GP.